So National 4-5 Chemistry, Atomic Structure. So this lesson is your final lesson on atomic structure, and it is to do with working out relative atomic mass, also known as the RAM. Now, the aim of it is to be able to calculate relative atomic mass and also to understand what relative atomic mass is. In terms of success criteria, we want you to be able to say what relative atomic mass means and be able to calculate relative atomic mass. Relative atomic mass is the average mass or weight of all the isotopes present in an element. They are listed on page 7 of the data booklet. However, in a National 5 or National 4 exam, you may be asked to calculate the relative atomic mass from information given about the isotopes. So here we have an example of an element that has isotopes and talks about its relative atomic mass. Chlorine has a relative atomic mass of 35.5. AMU stands for atomic mass units. This is due to the abundance of the two different isotopes present in chlorine. So there is a chlorine 35 isotope, of which there's 75% abundance, and there's also a chlorine 37 isotope, of which there's 25% abundance. When we take into consideration the mass of each isotope and their abundance, this works out to be 35.5. I will show you the equation later on in the slides. However, the equation will always be provided for you in an exam should you need to use it. It's not an equation that you need to remember. So here we have two isotopes. We have copper 63 and copper 65. The relative atomic mass is the average mass of an element's isotopes. More specifically, it is a weighted average of the isotopes. So copper has two isotopes, copper 63 and copper 65. And the relative atomic mass is 63.5. So that's not exactly the average of 63 and 65, but it is a weighted average. What a weighted average means is that if there is more of one of the two types of isotope, we count that value more towards working out the average. So because the the abundance of copper 63 is greater than the abundance of copper 65, it pulls the average more towards 63. And there is an exact way to do this, which we'll get onto. So relative atomic mass, the equation is if you've got two isotopes, an isotope 1 and an isotope 2, to work out the relative atomic mass, it is the mass number of isotope 1 multiplied by its percentage or its abundance. That divided by 100 plus the mass of the second isotope multiplied by the percentage or the abundance of the second isotope divided by 100. Now that might not seem really clear just looking at the equation, so I've got a worked example for you. So chlorine, the one that we introduced right at the start. Chlorine has two isotopes, chlorine 35 and chlorine 37. 75% of all the chlorine isotopes are chlorine 35 and 25% of them are chlorine 37. What is the relative atomic mass of chlorine? Well, we have the equation relative atomic mass is mass of isotope 1 multiplied by percentage of isotope 1, and then divide that by 100, and then add the mass of isotope 2, percentage of isotope 2 divided by 100. So isotope 1, we're going to say, is the chlorine 35. The mass of that isotope is 35, that's its mass number, and its percentage is 75%. So what we have is 35 multiplied by 75 divided by 100. Then for isotope 2 is going to be chlorine 37. And the percentage of chlorine 37 is 25%. So to complete the equation, it's going to be 37 multiplied by 25 divided by 100. And when we do those two calculations and add them together, we end up with 35.5, which if you check the data booklet is the relative atomic mass of chlorine. Now, as I've said, this equation will always be given to you in an exam if you're expected to do it, if you're expected to use it. It's not something that you need to remember. However, knowing what relative atomic mass can help you understand this equation better. So here is a question. It's from a past paper. Now it's telling you that there are equal amounts of two isotopes. One isotope has a mass of 14 and the other has a mass of 15. What is the relative atomic mass of this sample? So if you want to have a go at this question, you can pause the video. You might want to rewind back so you can see the equation to use it. But if there are equal numbers, that means that there's 50% of each isotope. So if you want to pause the video, have a go. And when you unpause the video, I'll go through the answer. Okay, so hopefully that's you back. And to do this, that's the equation. And this time we've got one isotope with a mass of 14 and it's got a percentage of 50%, and the other one has a mass of 15 and a percentage of 50%. So when we put those numbers in, it's 14 times 50 divided by 100 plus 15 times 50 divided by 100, which is 14.5. Now, because there's equal numbers of the isotope at 14 and the isotope at 15, you can just take the average of those two numbers. But that's only in the case where there are equal numbers of each isotope. That's why that question was only worth 1 mark. You did not have to use the equation. Here is another question, and this is a slightly trickier one. Hopefully you can read that question nicely. But it says the following is a graph. The following graph was obtained for a sample of lithium. And we can see that the graph has two values. We've got one at a mass of 6, which says that it has, if we're looking at the left-hand side, a percentage of 10%, and one at a mass of 7, which has a percentage of 90%. Now, the first question asks how many isotopes are present in the sample of lithium. To answer this question is actually really simple. All you need to do is count the number of lines on the graph. So we've got one line here and a second line there. That means there are 2 isotopes. That's all you need to do to answer that question. Now the next question is a bit more difficult because you have to use the information from the graph, put it in the equation and then solve it. Now what we have for the isotope with a mass of 6, we have a percentage of 10. For the isotope with a mass of 7, we have a percentage of 90. So when we put that in an equation, it is 6 times 10 divided by 100 plus 7 times 90 divided by 100. And when that works out, you end up with 6.9. That has been our introduction to relative atomic mass and an introduction to the equation. As I've said, that equation will definitely be provided for you should you need to use it in an exam. And this actually concludes all of our lessons on atomic structure for National 4, National 5. So I thank you for going through all these lessons, and hopefully I will catch you at another topic. Thank you.